Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy, and today we are continuing our series on index laws by looking at the first index law. Now, you might be thinking, the law, what's this got to do with maths? Another word for law is a rule, and today we're looking at how to multiply powers when we have the same base, and that's called index law 1. So you recall from our last video that we looked at the basic form of an index, or a power, or an exponent. We have a base, that's the big number at the bottom, and we have an index at the top, which is a number 10 in this particular situation. So this simply means 2 times 2 times 2 times 2. It's basically 2 multiplied by itself 10 times. So here is our first index law. You may want to write this down. It looks a little bit confusing. I'm going to unpack that for you. So firstly, it's a law or a rule. So it means it can be applied to any situation. Now your situation may not have the letter A as the base. You can see here, same bases of A. It may not have powers of M and N. However, you may be using numbers. So basically we set this up as a general rule that you can apply to no matter what situation you've got. When it looks like this scenario, then this is how you apply the law. So let me just talk about what it means. You can see that A and A are a common base. So you can only apply index law 1 when you have the same base. So whether that base is the number 3 or the number 2000 or an X or a Y, you can only apply this law if you've got two same bases being multiplied by one another. So our final answer is also going to have the same base at the end. Now you'll notice these are being multiplied by each other. So this is a law about multiplication. And you'll notice that the powers could be the same number, but they are, in this case, different letters, could be different numbers. So our principle that we're finding here is that when we have the same base and we multiply two different terms with the same base, then instead of timesing or multiplying the powers, we add the powers. That's our rule. So in this case, you can see they're added. So if this was a power of 2 and this was a power of 3, it's 2 plus 3. And it always helps when you're starting out as well, when you're applying this rule, to show you working by showing the addition here. So you notice then that that base does not change. We don't have M or N as part of our base. Okay, so I'm going to do this with a worked example. You'll start to see how it works. Now, in this case, I'm using just straight up numbers, no letters at all. Keep it nice and simple. So our rule was they had to be the same base. Are these the same base? Yes, they're both 4s. And the rule for the rule to apply, it has to be multiplied. So you can see in the middle, there's a multiplication. So our rule was that we simply add these powers. So we're going to follow that rule there. Sometimes it's helpful to start by writing the rule out until you've learned it off by heart. So following that rule, we're going to write that now as 4 to the power of 2 plus 3. So notice now what I've got is I've got my rule here and I've simply put into the question and lined it up so that it looks exactly like the rule does. And I've even shown my working with the 2 plus 3. Now, once you get good at this, you can work out 2 plus 3 in your head. You know, it's 4 to the power of 5. However, when you're starting out, it's always helpful to show that working, to show where that 5 came from. It's the 2 plus the 3 from our law there. Okay, now you might be wondering why this rule works. So what we're going to do is we're going to test this law by, we're going to expand the whole expression, put it in expanded form, and then we'll put it back into index notation and see how it works. So if we look at 4 to the power of 2 and we expanded that, that would become 4 times 4. And 4 to the power of 3 becomes 4 times 4 times 4. So if we now put that back into index notation, then I've got 1, 2, 3, 4, 5 of those 4s being multiplied. That's simply 4 to the power of 5. So you'll notice this is how the index law works. We've first expanded this out, and then this 2 here and the 3 here add together to become the 5. So this law is basically a shortcut. Every time we get one of these situations, we don't want to have to expand it out, especially if we've got powers of 10 or 15 or something like that. Writing that out and then shrinking it again would be really annoying and time consuming. So that's why we have this rule. It's a lovely little shortcut. So now we're going to introduce some algebra. So once again, we're going to apply our law. So applying that index law 1, I've got y to the power of 12 and I've got the same bases. That's the first thing you should always check. Have I got the same base? Yes, I do. What's the base? It's y. So now that means, and I've got a times there, I'm applying that law, 12 plus 2, and we know that makes y to the power of 14. So it's really as simple as that. All you need to remember is when you've got that times, it becomes a plus for the indices. So just be very careful to always check they have the same base. Okay, this time I've made it a little more difficult. This will probably be more of your A standard question on a year 7 or 8 exam, or a year 9 exam possibly, maybe a B standard question there. So this time I've actually got coefficients for these two terms. I've got a k to the power of 5 and a k to the power of 8. So I know that I can apply the index laws to this part here only, because these are the only two parts of the question that have powers. So the 4 and the 3 at the front, they don't apply to index law 1 because they don't have powers. These k's do. So they're the ones that have the same base, so I'm going to add those powers only. However, you might be thinking, what do I do with the 4 and the 3? Well, they're just normal numbers. They're coefficients of an algebraic term. You would remember when we multiplied, for example, 2a times 3a, it's simply 2 times the 3, smooshes on the front, and then the a's go on the end. Okay, so in this case, they're not powers, so it's just 4 times 3 makes 12. So let's apply index law 1 now to the rest of it. So this becomes 12, and then I've got the k, 5 plus the 8 in the power, which simply becomes 12 k to the power of 13. So this is where we have to be super careful, recognizing that this law only applies to powers, only applies when they're the same base, and only applies if there's a multiplication in between. So you've got to check off those conditions first before you get started. Anything stuck to the front just gets times like normal. Okay, let's do one even harder this time. I've added 2 different sets of letters in here, and we treat those differently because they're different bases. We've got 2 bases this time. We treat the 2 and the 5 as normal because they're just normal numbers with no power, and 2 times 5 makes 10. So that will sit at the front, but we've got this base of m, and we've got a base of n. So m will be treated separately, and the n will be treated separately. So let's follow our index law 1. We've got now the 2 times the 5 makes the 10. And then bring the m's together. We've got this m base here with an m base there, 10 plus 4. And the n, we've got 2 n bases there, 7 plus 3. This is where it becomes handy to start showing you working, because now it's getting a little bit harder to do it in your head. Now we can simplify that to 10m, because 10 plus 4 makes 14, 7 plus 3 makes 10. 10m to the power of 14, n to the power of 10. So maybe pause the video here, go back over the example, perhaps write it down in your exercise book, and just work out what's going on there. It's all about breaking this into little chunks. Coefficients first, these are our coefficients. So do your coefficients first, and then do it one base at a time. Well, did you find this video helpful? I sure hope you did. And here's how you can engage further with the channel. You can like and subscribe, hit that notifications button so you'll always know when there's a new video available. You can engage further with us by joining us on Facebook and Instagram. And if you've got any questions at all, don't hesitate to contact me at mcclutchymass@yahoo.com. Best not to put your questions in the comments, always difficult to answer there. But we do love to hear from you in the comments. If you found it helpful, why not tell us there too? Well, thanks so much for watching. I'm Natalie McClutchy. Have a wonderful day.